hit recording, but I didn't put where I was recording. Welcome to our Better Way Thursday tonight. Our guest is Kat Cosgrove. Did I pronounce that right?
You did.
Perfect. And she is giving a presentation called DevOps 101, CI through the ages. Am I remembering that right?
CICD, but that's okay.
Thank you so much. I am always learning new acronyms. And so I'm just going to turn the time right over to Kat. She has a great story, and I will let her introduce herself. Thank you so much.
Yeah. Alrighty, let's go. So just a heads up, this is a talk that was originally written to be part of a like 2.5 hour-ish long workshop. This is just a section of it. It focuses very, very heavily on like history and context, because people who are like new to technology or even just new to DevOps, they don't teach you this in school. Even if you do like get a 4-year degree, and they don't teach this to you in coding boot camps. And unless you understand like the history and the context of some of these tools, it can be really difficult to learn them because you don't understand why it's really useful. Like they tell you what it does, but not like why that actually helps you, or like how we accomplished things before that. So a lot of this is going to be history, but at one point I'm also going to go next, actually, I'm going to go off script and talk about myself much more than I usually do because I was asked to. So I will do that. But welcome to DevOps 101, CI/CD through the ages. My name is Kat Cosgrove. I'm a developer advocate at JFrog. What that means, I've said this a couple times, is that my job is to be a software engineer with social skills. So I am still a software engineer. I still write code. I still build all of my own demos, but I don't write production code anymore, meaning I don't write code that like other users, that like end users like y'all or whoever actually uses as part of an app. I only write demos and proofs of concept. So my code is meant to be seen and read by other humans. So the decisions I make while writing code are not necessarily decisions that like actual software development teams would make, because readability is more important to me than like being optimized. But I didn't get here in like the most entirely traditional way. Developer advocates are weird in that the title is pretty new. So there's like a pretty wide breadth of backgrounds for developer advocates. Almost all of them were software engineers before, but some of them were also community managers or technical writers before. I was a software engineer before, but I did go to college. I did not go to college for computer science. I also dropped out of college. So I'm not ashamed of that. And it's not really a barrier in tech anymore. Even like FANG companies, when you hear people say FANG, they mean Facebook, Apple, Amazon, Netflix, and Google, which are the companies that typically pay the most. Even they don't really care if you don't have a college degree or don't have a computer science degree anymore. It really doesn't matter, which is rad. But the point is, I spent a lot of time working as a bartender. I was a teacher for a while at the coding boot camp I ultimately went to. I spent a long time working at an independent video rental store. I was their in-house horror expert. So I spent all day watching and talking about movies for several years, which was really cool. And I miss that. And I will eventually hit the startup lottery and quit tech and go back to doing that, but it does not pay the bills. So, you know. Anyway, ultimately I started like freelancing, doing like some freelance web development for a while. I was building people like WordPress and Joomla sites for like local small businesses, for like fencing clubs and stuff. My husband is a fencing coach, and fencing clubs pretty universally have bad websites. So I was building them websites. I had taught myself HTML and CSS and JavaScript and a little bit of PHP out of necessity. I don't like PHP and wouldn't really recommend that you learn it as a first language today. But after a while, even though it was paying the bills, it was really stressful. Freelancing kind of sucks because you're responsible for all of your own, like, everything at all times. And it's hard to deal with. You don't have a buffer between you and a bad client like you do when you just work as a software engineer, and you have to deal with that entirely on your own. You also, the tax situation is really complicated when you're a freelancer as well. And I got super tired of it. The freedom is nice. I moved to Budapest for 4 months for like no reason, just because I could, because I was a freelancer, and that was really cool. But the ability to do that was ultimately not worth it for me. So I went to a coding boot camp here in Seattle. It's called Code Fellows, because even though there are a lot of them here, Code Fellows was the one with the reputation for having a very difficult curriculum. And I wanted to make sure that I actually learned difficult, relevant things rather than just getting a cert and hoping that I didn't get fired, you know? So Code Fellows also gave me a diversity scholarship because women are like radically underrepresented in technical roles. So I got a diversity scholarship at Code Fellows that paid for 15% of my tuition. A lot of coding boot camps offer that. So if that's something that you're like interested in looking into, eventually consider it. Code Fellows does also have like night classes, and I think they're fully remote now. So I think they're taking people from like all over the world instead of just from Seattle. So it might be worth looking at. But I did that. I went to 201 and 301 there, which are all JavaScript, HTML, and CSS. Then I took 2 months off to work there as a TA before I went into 401. At that point, I had a decision to make because they offered 401s in multiple languages. They offered it in JavaScript, which I already knew some of. They also offered it in Python, and they offered it in C#. And I ultimately chose Python for the following reasons. I wanted to learn another language. Once you already know a language, picking up a new one is much easier. And I didn't want to be a web developer anymore. JavaScript is for web development. And while, yes, lots of standalone applications now are made with JavaScript, because Node.js is a thing and Electron is a thing, like Slack, if you have ever had cause to use Slack, that is a JavaScript app. It's running in Electron. But it also leaks memory really badly, which is something you may not understand. If your computer is running really slow when you're running Slack, it's because Slack leaks memory because it's a JavaScript app. Chrome, like the web browser, it does the same thing. So now you know why Slack might do that to your computer. But I chose Python because Python is used very heavily for data science, and that sounded cool to me. Ultimately, though, that's not what I ended up doing, actually. I got a job fresh out of boot camp at JFrog as a software engineer working in embedded Linux development, aka IoT. So that's software development for very small, very low memory devices. I probably have one on my desk somewhere nearby. Oh, I've got this car. So this thing, this is a self-driving car, a very small self-driving car that I built. And this big board is a Raspberry Pi compute module. So it's a Raspberry Pi with just a little bit more RAM and a little bit more processing power and way more stuff to plug into it, you know? So I drove straight into the deep end from learn how to be a web developer to learn how to be a data scientist to surprise, you're doing embedded Linux development on a very small self-driving car. And also surprise, you have to learn Kubernetes immediately. Some of you may have heard the word Kubernetes before, and it gets like waved around like a digital boogeyman because it's complicated, but it runs a lot of things. It's not actually that scary. It's just that the way we teach it is bad. So it comes across as scary, but I had to learn it the bad way, you know? And I spent a year doing that, a year as a software developer for embedded Linux, at which point we built a very cool, very flashy proof of concept, taking software updates for a car from something that takes currently, for most cars, about 8 hours and requires physical access to the car. There's like 6, 7 computers in your car probably. And there's no way to update them remotely. They have to be physically accessed and they have to be flashed. You have to like wipe the whole thing and put new software on it. You can't just update it as it is. And we thought that sucked. The only real notable exception at the time to this was Teslas, which can update over the air. Now BMWs and I think some Mercedes can do it, but they can do it because of this proof of concept we built. It now takes about 35 seconds to update an application running on one of these cars, which is cool, right? It's really, really flashy. It was, I was extremely out of my depth when I did this. I had to learn Golang, which is not a language that I really want to write more of, but it's very popular in the cloud native space, which is where I work. But we got a lot of requests to talk about this at conferences, to like present our research to people. And the other 2 engineers on my team just had no interest in being on stage. They really did not want to do it. And I don't really care. I spent some time as a teacher. I'm very used to talking in front of crowds. It doesn't bother me. So I did it at like 2 or 3 conferences. And from there, I got poached. JFrog hired a new head of DevRel, and they were like, hey, you're actually pretty good on stage. Do you want to just do this instead? You don't have to write production code. You can build whatever you want. You go talk about it, and your whole job is to just be smart and talk to people. And that seems like a pretty good gig to me. So that's how I ended up where I am. Before I dive into the talk, just FYI, this was written for people who are either like working or who are junior developers or who are like trying to be junior developers. So while I do try to like limit the use of jargon in this talk, and I will stop and explain any jargon I use, if I say something that you don't understand, if I use a phrase that's unfamiliar to you, you can just like, I'll try to keep an eye on the chat. Just say something in the chat and I will stop and define it for you. Because I do think that the outrageously large number of like industry specific terms and abbreviations we use is a huge barrier to entry. So I do my best to avoid that. All right. Here we go. So the jargon section. DevOps specifically, DevOps means developer and operations, but I will go into that in a little bit more detail. DevOps specifically has a ton of jargon in it. This is problematic because some of these concepts are actually like pretty new, and also the definitions have changed over time. Some of these concepts have been around for a long time, but they don't mean the same thing that they did 20 years ago. So is this all software? Are these all buzzwords? Like, is DevOps a methodology or is it a tool set? Is any of this going to make my life easier, or is it actually just like marketing? A lot of the documentation also kind of assumes that you already have a ton of context, or assumes that you're proficient in some related tooling, and that doesn't make it easy to learn. That is a result of things being written by people who are experts who don't remember what it's like to not be an expert anymore. This is normal. This is human nature. We all do this. You are all going to do this eventually. And the only way to not do this is to like actively try to remember what it's like to not know something. Hopefully this talk clears some things up and some of these concepts are easier for you to learn afterwards. The first thing I'm going to talk about today is CI/CD as a whole, and first what it stands for. The CI in CI/CD stands for continuous integration, and the CD can stand for either continuous delivery or continuous deployment. They do mean different things. I don't like that they mean different things. Regrettably, I have no control over what the industry decides to call things. I know it sounds like it's already getting kind of irritatingly complex, but I will explain the difference between the two. We're going to start with continuous integration though. Practicing continuous integration means merging all of the developer's working code back with the source, like your repository on GitHub or whatever, multiple times a day. Not just once, not once a week, not once a day, multiple times a day. In order to do this safely, it requires a series of automated tests, build and unit tests, if possible, to ensure that none of the proposed changes to the code cause problems. But the result is that bugs and integration issues are discovered much earlier in the development process. Since like ideally a build is triggered with every single commit, that means that failures are caught by the developer immediately and corrected, because your CI system is going to find a failure because your tests are going to run with every commit and it's going to bounce it back to the developer, which is rad. This also does force engineers to write code that's more modular, which makes it easier to support later on, because ultimately, you know, humans are reading your code, not just the compiler or the interpreter. This is actually pretty old though. Continuous integration has been a thing since the early 90s. However, we didn't always call it that, and some of the implementation has changed, but the spirit has remained the same. You merge changes into source in much smaller and much more frequent increments, test that the project still builds and runs with those changes, and make sure that your engineers are all working on the most recent version of the source. If you do this, you won't end up with a ton of merge conflicts, and you won't have a bunch of surprise problems when it comes time to build. This was first proposed in 1991 by a man named Grady Booch. He wrote a book called Object-Oriented Analysis and Design with Applications, which is still somewhat relevant, and it has received a couple of updates since then. I wouldn't say that you need to go out and read this like right now. This is a go out and read it like maybe later on if you get like really into object-oriented programming for like historical context, but it's not necessary for like a brand new newbie. We called this the Booch method at the time, which I still think is funny. And it advocated for more frequent use of things called classes and objects in programming instead of just like YOLOing everything into a series of functions. And the idea here was to simplify design, to make it more human readable. His version of continuous integration did not suggest releasing multiple times a day, though. We didn't get that until 1997 with extreme programming. This built on the Booch method by advocating for releasing multiple times a day. This was a game changer, honestly, and I know the name sounds like ridiculous now, but it didn't mean extreme in like a 90s X Games edgy product marketing kind of way. It meant taking like concepts and paradigms that were already accepted parts of software development and then taking them way further. So an example of this is code review has been a thing for a very, very long time. So somebody else looks at your code, like a human looks at your code and reviews it before it gets merged, right? But what extreme programming gave us was pair programming. So when you're doing pair programming, you're essentially undergoing code review the whole time you're writing code. So that's what it means by like taking an accepted part of software development and taking that to the extreme. So it's not just one code review, it's continuous code review. And from there, we went to like Scrum and Kanban and Agile and on and on and on, all with like just one goal in mind, making it easier to write higher quality code and get it out to the users faster. In the early days, we did recognize that we needed to be releasing more frequently, but we didn't really have the tools to do that. Continuous integration isn't just like, it isn't just a concept, it isn't just a practice, it requires tooling to actually do. And we didn't get the first open source tool to make continuous integration easier to achieve until 2001 with the release of cruise control. You can go back and look screenshots of this on Google Images, and it does look pretty primitive now, but at the time it was definitely revolutionary. This is not the actual logo for cruise control. I just could not find a version of their logo with a transparent background for this slide because the ping image format, it wasn't supported by browsers until Internet Explorer 9, which was released in 2011, a whole year after the last update to cruise control. So this is like ancient history as far as the internet is concerned. That's how old cruise control is. And if you want to be just like a little bit uncomfortable, people still use cruise control. Like this thing is actually still being used, which I think is bonkers. But here we are. With cruise control, we finally had a system that we could install and stand up ourselves to automate the management of builds, which allowed us to release way more of them. It also integrated with your IDE. IDE is integrated development environment with your code editor. It integrated with your code editor if you were using Eclipse. You specifically had to be using Eclipse, which to be fair was very popular at the time. And also cruise control was Java specific. So it made sense to integrate with Eclipse. I don't think JetBrains was a thing yet at the time. JetBrains is now like very popular. And the downside here is that if you were writing another language, you had to use a completely different continuous integration system. There were different variants of cruise control. At least there was a Ruby variant. So if you were writing Ruby, you could still do this. But otherwise, you had to be writing Java. I don't write Java. I also don't like Java. So this upsets me. Eventually, it was overtaken by Jenkins. And Jenkins is still pretty widely in use today. It is still like actively developed. It still gets new features. It supports a ton of different languages. You don't need to install different versions of it. And it can be made to do almost anything you want. It has an enormous community around it. So if you do run into difficulties, when you do run into difficulties, because it's complicated, it's almost a certainty that someone else has run into that specific problem before and documented it, because it's like really, it's so widely adopted. It's stable, it's secure, and it's popular. However, Jenkins is starting to show its age in a pretty bad way. You have to stand up infrastructure and install it yourself. You need to have your own host for Jenkins. It is a separate asset that you have to maintain, and somebody has to be responsible for maintaining it. I'm not sure I understand the difference between Jenkins and pull pushing from a GitHub repo. So GitHub is your source control. You know, that keeps track of like versions of your code. It's not capable of doing things like actually building it. If you're writing a compiled language like Java or Go or C or C++, GitHub can't do that. GitHub can only store your code. So Jenkins and tools like it are responsible for running tests on your code. It comes after source control, usually. So you commit to source, you open a pull request, at which point your CI system like Jenkins picks up, and it will try to run tests on your code. It will try to build your application if it's a compiled language, and any other number of steps that you want to automate away. And if those checks all pass, then your pull request will merge back into main. But this is it's a safety net to automate things that you're probably doing manually now, so that you don't have to keep doing these things manually. That's ultimately what all CI systems do, but I will go more into that later. So on Jenkins, they do have a like more modern version called Jenkins X. That's their like cloud native offering. Cloud native is a buzzword, but it is a buzzword that is regrettably very here to stay, because it means applications that are like built and designed and architected to run on cloud providers. They are like not intended to run on a local machine or on a physical machine that you have access to. They are built and intended to run on things like GCP or AWS. GCP is Google's answer to AWS, and it is better. I have opinions. So on that, the cloud. Rapidly, self-hosted, self-managed CI tools like Jenkins and the now defunct Cruise Control are being replaced by cloud services that you don't have to babysit, like Travis CI, Circle CI. GitHub has one now too. It's called Actions. These things also support dozens of different languages and build environments. They know how to deal with cloud native technologies like Docker and Kubernetes. They integrate directly with a bunch of other services to handle things like deployment or analytics or log tracing or security or whatever. It's both more flexible and lower maintenance. The downside here is that you do lose some security by not being 100% in control of your CI system. For the overwhelming majority of people and organizations, this is a very acceptable trade-off. The risk is extremely low. That's just CI though. We have to talk about CD because these two don't work without each other anymore. We have two CDs to talk about. Continuous delivery means what it says on the box. Your software updates are continuously delivered to the very end of your deployment pipeline, but they aren't deployed yet. In concert with continuous integration, this means that you should have the ability to deploy a new build very rapidly because you've automated all of these quality gates that would otherwise need to be performed manually, like building and testing. That reduction in manual labor means you get to release a bunch of small changes rather than one huge update every couple of months, or worse, as I will talk about in a few slides. Since you're now making smaller and more incremental changes, you can also be more confident that your release isn't going to break when you deploy to your users, or at least that if it does, one, you're more likely to know what the problem is because there aren't a ton of feature adds included in that build. And two, because you're using CI and a CD, you can just patch it faster. It just makes it much faster to like release a fix or roll back. Continuous deployment is very similar, but it goes one step further. The deploy step is automated too here. Most people in the industry you ask now will say that the CD stands for continuous delivery, not continuous deployment, because automating away the deploy step is controversial. It makes people uncomfortable. Personally, I am a huge fan of it. I work for a DevOps company, so I get to see a lot of people trying this stuff in the wild, a lot of statistics on how these things typically go. And what I have learned is that having a human involved in pushing the big green button to actually roll it out to your users, that does not reduce the incidence of bad updates in the wild. It is a safety blanket. That is all it is. It is a safety blanket. It is a waste of time. You are better off just automating the deploy as well and focusing on being able to roll back or push a fix more quickly. Humans are just, we're very bad at repetitive tasks. You know, there's a hard ceiling to how good we can get at something by doing it over and over again. And with menial tasks like pressing the deploy button, that ceiling is very, very low. And unlike computers, people get bored and we get tired, and like maybe you got into a fight with your significant other, or like you slept wrong and your neck hurts and it's making you cranky. You're going to make a mistake, and that's normal and that's acceptable, and you should not be punished or fired for it, but it is going to happen. And the computer is not going to have those problems because it is a computer. So if it's possible to automate something, you should do that. Both continuous delivery and continuous deployment get you a lot of that. I just am personally of the opinion that a human does not need to push the big green deploy button anymore. It's ridiculous. So at a super high level, this talk is not done yet, by the way. CI/CD is just the term for the marriage of these two concepts. It is an important part of DevOps, since automation and efficiency is like all DevOps cares about. And one doesn't really work in the context of DevOps without the other. We need both. Doing this gets you a faster, more reliable release cycle. You can add new features or bug fixes much more quickly, since you know your engineers are always working from the most recent source, and you know that there are tests, and you know that it builds. there aren't a bunch of manual steps involved for like you or for the QA team or whoever. Instead, you just push code or open a pull request, and all of those steps are taken care of for you by your CI/CD tooling. You don't have to worry about anything but writing code. You can stay in your editor, which I love personally. I'm super lazy. So like the less time I have to spend doing other stuff, the better. But how does this actually work in practice? To start, you need a CI/CD tool. These things are kind of like rolled into one now. I don't think that there are any on the market that only do like one or the other. And this is the thing that automates everything for you. It does take some time to set up at the beginning. It is going to save you a lot of time in the long run, so just do it, especially if you like being lazy. I'm willing to put in a lot of work at the beginning of a project to be able to be lazy later and not have to worry about doing the same thing over and over again. The specifics of configuring any of these tools does vary, so you would have to check the documentation for your chosen tool, but broadly, they all work the same way. You set something as a trigger, like telling it to watch your source repository for a commit or for a merge. You then configure a series of steps, each with pass-fail conditions, like telling it how to run your unit tests, telling it how to build, how to scan for like known vulnerabilities, or how to deploy to AWS or GCP or wherever your thing lives. If this pipeline is sufficiently detailed, and you totally can get it there, you really don't have to do anything but write code and push. Like most of my CI systems, I set to trigger on a push, not on a pull request. So I just straight up don't worry about it. But usually this is all defined in a format called YAML, which is a human readable data serialization format. It looks a lot like JSON without the curly braces. It is tab delimited as well. So it's not, you can't just go wild. The tabs and spaces matter. A complaint I have about YAML is that tabs and spaces really matter a lot in it. So it's easier to like accidentally screw up your YAML and end up with something that your CI system can't read because you have a tab instead of a space somewhere. But inside of these steps, you are often just bash scripting. So if you can do it inside of your Unix terminal, you can do it inside of your CI system, which is really, that makes it much more approachable. I wish more people said like literally just write bash. That's how CI/CD works. But that is how it works. You're just writing bash, because what's happening inside of your CI system is it is launching a container that is running a whole entire operating system. It's usually Ubuntu. You can you don't know any bash, that's okay. There are like a wealth of free online interactive tutorials for bash. Code Academy has a good one. So you can learn bash there. I think Khan Academy has one too. Anyway, most of these also do have like a web interface with a graphical overview of what your steps look like, with some fancy logging output so that you know exactly what's going on and when you are not in the dark. When something goes wrong inside of your pipeline, it is typically very quick and very easy to tell what failed and where. So now we kind of know what CI/CD is. So here's what goes into an update and why it's important. If you are around my age or older, I am 31, you probably remember how much drama used to be involved in software updates. They were large, they were infrequent. It was not unusual to see like a year or more in between software updates. It truly sucked. There was a fairly significant chance that the new version would be like wicked buggy in some way that was going to break whatever you were trying to do with it. And it was just generally like a really inconvenient experience. If you are younger than me, that might sound absolutely bananas to you, but really it used to be totally normal to go a year or more waiting for an update to an application. And I can't imagine doing that anymore. I can't imagine as a developer like writing and releasing code that way anymore, but it was definitely the norm, regrettably. In a lot of situations, it actually wasn't even possible to just download an update, even well after the advent of the internet and like it becoming ubiquitous. The manufacturer would have to provide you with the update via some kind of physical media, whether that meant a like floppy disk or CD-ROM or a USB drive. And the last time I had to do this was not that long ago. It was 2009. I was updating the software that the video store I worked at relied on to operate. And in 2009, they literally had to snail mail me a thumb drive. They would not email me. They wouldn't email me the executable. I tried. They really, really, really would not do it. They straight up mailed me a thumb drive. And to be fair, this particular application was, the company's out of business now, which should not be a surprise to anyone since they just like refuse to modernize. But they didn't have license keys for like verifying that you owned a copy of the software. Instead, license verification was done by detecting a physical dongle, like something that had to plug into the computer that required a serial port. And by 2009, some of you don't even know what a serial port looks like, because some of you look very young and like you've never seen a serial port, because by 2009, it was pretty uncommon to see, yes, that serial. Even by 2009, it was pretty uncommon to see a workstation with a serial port on it. So this was a problem, right? And it was still a thing in 2009. To be fair, some things do still work this way in 2021. However, it is exceedingly rare outside of a very small handful of industries, and it is almost always like an extreme security system thing. Yes, lab equipment, medical devices, a lot of stuff used by the federal government will still have serial ports on it. Also, it's not uncommon to see like enterprise equipment still has serial ports on it. Like we have yeah, Department of Homeland Security. Yeah, that makes sense. A lot of enterprise equipment still uses serial ports for stuff. Phones have also suffered similar problems with the CD side of things. Back in the 90s, there was not a way to update the software on your phone. So if you had the Nokia that did not have Snake on it, and you wanted the one with Snake on it, you could not update your phone to get Snake. You had to buy a new phone. It sucked. It didn't last very long. Eventually, we did get software updates, but it wasn't great. You had to plug the phone in, and there was a special application you had to run on your computer to update it. That actually continued for a very long time. I remember having to do that with my Samsung Galaxy 2, which is not that old. You know, that was about 10 years ago. And once cloud storage became a thing, this became less painful, but like software updates became wireless. But if you got a new phone, you had to transfer data from like the old phone to the new one with a physical cable. This is also not that long in the past. I had to do that like 6 years ago when I switched from a Galaxy to a Pixel. But now it's something that you don't think about. You don't notice your phone updating anything other than its operating system anymore. The apps get updated overnight as long as your phone is plugged in, usually between the hours of 2 and 4 in the morning. And it doesn't even ask you. It just does it. The only thing it asks you about is a like full operating system swap, you know? And when you switch phones, there's a little bit of lag time while you know, data gets downloaded from the cloud or apps get reinstalled, but it's all pretty seamless and it doesn't require you to pay attention anymore. That's CI/CD doing that in some ways. We have gotten much better at this, and the prevalence of cloud computing has helped a lot, but we are still not perfect, and there have been some disasters. It turns out that not updating can be really expensive, especially if you don't do it often and you don't do it automatically. In 2012, a bad software update caused a pretty significant stock market disruption and tanked the value of a company called Knight Capital. They were a trading firm. Notice that I said were. That specialized in automated transactions on the New York Stock Exchange. And one day, it kind of came crashing down for them. They were not automating their updates or their deployments, and they weren't updating all that often either. Remember that humans are not good at repetitive tasks, and we are especially bad at them when we get no practice and every time you're nervous about it. So two things contributed to this disaster. When the engineer was updating the 8 servers that ran Knight Capital's automated trading, he forgot one. Only 7 of the 8 had the new software. The new version had also reused an old API endpoint, but changed the behavior of that API endpoint in the new version. So you might be able to guess where this is going. When this went into production, it was immediately chaos. So requests to that old server running the old API endpoint destroyed the share price of 148 companies. Engineers responded by taking the 7 updated machines offline to roll back the software, assuming that the new software was the problem, which increased the load on the one machine that was never updated to begin with and still running the old bad version. They had no logging in place, they had no monitoring, and they had no alerts. So they had no way to know what was going on, and they sat there desperately trying to figure out what had happened, losing money minute over minute. This bad update was live for 45 minutes, and Knight Capital lost $440 million. They went out of business because of this. This was completely preventable, and it was not that engineer's fault. He was set up to fail, like absolutely that poor person was set up to fail. Not their fault, should never have been put in that position, but it happened. Had a bad day, got distracted, was nervous because you don't deploy that often, and a mistake happened. There were a lot of problems here. It wasn't just the fact that they weren't automating their deploys and they weren't testing and they weren't doing all of these things. But to me, that's the most egregious mistake. Reusing the API endpoint is also maybe a problem, probably a problem. I wouldn't do it personally, but there are situations where it could be fine. So I'll let that one go. But the biggest issue here was if this had been automated, this would not have happened. Just straight up, because all 8 of those machines would have been updated. There's also a security angle that all of you are you've probably heard of this. I'd be surprised if any of you hadn't heard of this, but you might not know exactly what happened, like under the hood, what was the actual cause. So this is the story of the Equifax disaster. In September of 2017, Equifax announced that a serious breach had occurred between May and July of that year. The first month is important there. It was May that the breach began. So the names, addresses, birth dates, driver's license numbers, and social security numbers of just shy of 149 million Americans, plus a few Canadians, had been stolen. The hackers had exploited CVE 2017-5638. Publicly disclosed vulnerabilities are always assigned an identifier like that. It's called a CVE. The first 4 numbers are the year. The next 4 are qualifiers for like months and dates, etc. And this was a vulnerability in an extremely commonly used web framework called Apache Struts, specifically in Struts 2. Talking about how this vulnerability actually works is kind of out of scope here, but the gist is that it would allow an attacker to remotely execute commands with whatever authority the web server had. This is not a vulnerability that flies under the radar. Remote code execution exploits are about as serious as you can get. So this was immediately assigned a CVSS score of 10, which is as extreme as you can get. It means if you have this problem, you need to update to the fixed version immediately. If you aren't sure whether or not you have this problem, you need to check. It's an emergency. This was very big news in the security world. Like, it wasn't big news in a way that like non-tech people heard about it, the way non-tech people heard about Meltdown and Spectre, but for engineers and anyone who works in security, this was extreme. It was also disclosed and published in March, 2 months before Equifax was breached. They had 2 months. to find out whether or not they were vulnerable to this and fix it. And they didn't, obviously. So once they discovered the breach, it still took them 2 more entire months to find and upgrade all usages of the vulnerable version of Struts. Lawsuits were filed, a bunch of them, resulting in a regrettably small $575 million payout and credit monitoring for those affected. But there were so many people affected by it that most people got nothing except for being paranoid about their credit for the rest of their lives, which is pretty terrible. This was caused by a number of things. If they had been doing things in like a more DevOps kind of way, if they had another tool managing their build artifacts, their binaries, if they had vulnerability detection as part of their CI/CD system, they would have known as soon as this CVE was publicly disclosed and indexed that they were vulnerable to it. If they had been using CI/CD, they would have been able to find all incidences of Struts 2 and switch it to the fixed version. Fixing this was literally as simple as just updating the Struts 2 dependency to a new version. It was a 1-line change everywhere it was used. And they couldn't do that. And as a result, it caused a nationwide catastrophe that a whole lot of people are going to have to just deal with for the rest of their lives. So CI/CD does a lot more for you than it looks like on the surface. It does make things easier. It does make things faster, but it also makes things safer and less expensive. So to wrap things up, CI/CD is a combination of a methodology and tooling with the goal of increasing your speed and efficiency as a developer by automating tasks like building, testing, deploying, and detecting vulnerabilities so that you can do those things more often. The benefit to you is that you get to push updates more often, you detect bugs more quickly, and bad releases don't make it into production as often. It has been around for a long time, longer than we like to think, but it's also changed a lot over the years. It's become much more useful and accessible with the popularity of cloud computing. And it's honestly changed so much that it's virtually unrecognizable from the way it started in the 90s. And we should frankly call it something else at this point. I hope that I've helped you understand what CI/CD is and why you should care about it, and what it does for you and how it's changed over the years. I will take some questions. I have plenty of time, but if I can't get to you or you think of something later, you can DM me on Twitter at Dixie3Flatline. You can also try to email me at work, but I'm not the most reliable at responding to emails in like a super timely manner. Fair warning, it's a pandemic. I get a lot of emails and it's a mess. It's a mess in there. Anyway, questions? Anyone? Nope.
There were lots of words I didn't understand, but I am convinced of the efficacy and necessity of doing what you've said.
Yeah, unfortunately, I do have to use a lot of words that are difficult to understand in the course of doing this, but in the like 2-hour-long workshop, I hate that I have to use so many like pieces of domain-specific language doing this. In the full-length workshop, I include a glossary. Like there's literally a glossary in the GitHub repo.
Kat, I want to say that even though I am probably the least tech savvy person on this call, I was still able to understand most of what you talked about. So thank you so much.
Good, I'm glad.
One of the things that we like to focus on with our group is identifying pathways and interest levels for what direction we want to go down. And so if someone was interested in in working in DevOps or understanding these tools, what would be the right way for them to learn more and start going down that pathway?
So I would say that now is actually like a really rad time to be doing that, and it's much more accessible than normal. Unfortunately, thanks to the pandemic, because DevOps people love talking and we love conferences and we love getting other people to do DevOps. So we have like a buttload of DevOps conferences, and a ton of them include tracks specifically for like approachable 101 level content. A lot of them are tutorials. They're not all like super intense technical deep dives that require you to be an expert. And because of the pandemic, all of these conferences are virtual and the overwhelming majority of them are free. So I would say do that. The most popular series of DevOps related conferences is DevOps Days. DevOps Days is a global conference series. So there are DevOps Days conferences in cities all over the world. And because all of them are virtual right now, you can attend any of them. The next one is DevOps Days Kiev, which is April 20th to 22nd, I think. But if you just go to the DevOps Days website, you can find a list of all of the different events. And yeah, like I said, they are free. So I would definitely start there. And also we're like super duper friendly. So just like talk to people at the conference. There's usually like a chat system built in. So just talk to people. We're friendly. Mark, go for it.
Thanks. So just sort of out of interest, is there a specific software to do this CI/CD thing that you would recommend just for someone who wanted to do it on their own, just for a project or something like that?
Do you, yeah, I would start with GitHub Actions. Personally, my actual favorite is Circle CI, but GitHub Actions is built into GitHub. It's like right there. So it's probably a better place to start for learning it. It's very accessible. It's very well documented. And if there's something you want to do that you don't really quite understand how to implement yourself, GitHub Actions does support. They named this really poorly because the whole tool overall is called GitHub Actions, but there are also like specific smaller like packages of steps written by other people that are also called actions, and you can import other people's actions into your workflow. So I would start with GitHub Actions, but my actual favorite is Circle CI.
Cool, thanks.
You're welcome. If you are not comfortable talking on the mic, you can also just put your question in the chat because I have that open as well. Anybody else has a question? It doesn't have to be about DevOps. You can ask about my hair dye, I don't care.
Well, I am super glad that you came and do this because I actually did one of your workshops and I was just amazed at your story, and I was just learning JFrog because I was super interested in like just learning about other technologies. And I guess like I'm in the coding bootcamp right now through vSchool. And I guess for me, it's if I wanted to transition, like how would I be able to, I guess, to be a little bit more prepared if I was to start looking at DevOps positions?
For DevOps job positions in particular, so it's getting kind of conflated with cloud native a lot. So it doesn't, you don't need to be an expert with like Docker and Kubernetes, but those are things that it helps to understand, like conceptually, to understand Docker and Kubernetes. For sure, you don't need to actually like be able to stand up your own Kubernetes cluster and administrate it in an effective and secure way, but you just need to know what it is. Can somebody spell those words in chat? I can do that actually.
Okay, I was gonna say, Kat, if you're talking, if someone else knows those words, but I've heard them before. Okay, thank you. Thank you so much.
Yeah, there they are. Yeah, Kubernetes is a Greek word. It means the steering wheel of a ship. But yeah, understanding container technologies like Docker and Kubernetes is helpful because the overlap is extreme with cloud native and cloud native infrastructure. Like infrastructure is handled by the ops team and cloud native infrastructure is Docker and Kubernetes. So get familiar with those things. if you are going for a company that is like less bleeding edge, which is okay, like the bleeding edge is really stressful, then you may want to understand tools like Puppet and Ansible. I will spell Ansible in the chat as well. So those are good things to understand. The most common CI/CD tools by far are Jenkins, and then probably Circle CI, maybe so Amazon AWS has like a built-in thing that's frankly sucks, but people get stuck with like a vendor lock-in and they just use all AWS stuff or all Azure stuff or whatever. So there are their CI/CD tools as well, but Jenkins is the one that's the most widely applicable, and it's also free. So you can just stand up a Jenkins server locally on your machine and use that to learn rather than like paying for time on a cloud provider. GitHub Actions is also free up to X number of minutes. Circle CI and Travis CI are also both free up to X number of minutes, and they're very popular with open source projects. So those are really, really good things to learn. I use Ansible for my undergrad research deployment. Yes, Ansible is still very, very popular for managing deployment. Yeah, I still really like it. It's not actually a dinosaur. It absolutely has a purpose. It has problems, but it's very, very good at what it does. And if you're not doing everything cloud native, Ansible is very helpful.
What did you get? You said you also went to college too, but you dropped out.
Yep.
What were you studying in?
Biochemical engineering.
Nice. So did you ever had to, like when you transition over to tech, did you ever felt like you went through the imposter syndrome? And if you did, how did you overcome it?
Oh yeah, that doesn't go away. Yeah, sorry, that doesn't go away. Yeah, like constantly. And I don't believe I'm an expert in something until like somebody I respect tells me I am. So I've accepted that I am absolutely an expert in Kubernetes. That just is a fact. But yeah, the imposter syndrome doesn't go away. You get better at recognizing it. And that helps a lot. Recognizing when you're being irrational. It doesn't really make you feel better, but it does allow you to like continue to function instead of self-destructing. You know, the way I handle it is I have a couple of friends who I trust implicitly, who are also much smarter than me. And they never make me feel stupid. To be clear, it's important to like find friends and mentors who are smarter than you, but don't ever make you feel like that's a bad thing. I have a couple friends like that. And if I am not sure whether or not I'm being an idiot, I will go talk to them because I trust them to tell me honestly whether or not I'm being stupid. And if they say, hey, Kat, like what are you doing? Like, what on earth is this? This is a mess. This is so wrong. I'll be like, please help me fix this. And they will do that. And if they say, no, like this is correct, you have gotten trapped in your own head again, I will just believe them because I trust them. So those things help with managing imposter syndrome, but like as a thing that happens, it doesn't really go away. You really just get better at recognizing it and managing it, unfortunately. Wish that was not so. I wish I could tell you it stops, but it doesn't. Yeah, that's correct. You do have to just pretend you're a good programmer forever. Look, I've never written, good code doesn't exist. All code is bad. All code sucks. The best code is code you can delete. Seriously, all code is bad. We have changed so many times over the years, like what the definition of good code is, that it literally doesn't matter. Does it run? Can other people read it? Can other people understand it? Fine, great, good enough. Because 10 years from now, the definition of what good code is going to change and your code is going to suck. I look back at code I wrote 6 months ago and think, oh my God, I'm a big dumb idiot. Like, why did I do that way? And everybody does that. Everyone is like that. The only people who aren't like that are like obnoxious lone wolf 10x engineers, and you don't want to work with those people. Nobody wants to work with those people because they're insufferable and they make everybody feel bad about themselves. So accept that your code is bad. Everybody else's code is bad too. The downside to finding out like exactly how all of this stuff works is that you're like way more terrified of computers, and eventually you fall on the side of thinking maybe computers were a mistake. Like, you get there eventually. Programming. I make the computer go beep boop. That's what I do. I don't even know which language is the best one to start learning. So it depends on what you like. My personal opinion is that Python is the best language to start with because it is human readable. It is very human readable. The standard library is huge. So there are a lot of things that you don't have to worry about trying to import from third-party packages at first until you want to do something that requires importing from a third-party package. And it's also, it's like the Swiss Army knife, the multi-tool of programming languages, because it can do most things. And it's not just that it can do most things, it's that it's even considered like good practice to use it to do most things. It's not the best tool for all of these things, but it is a tool that is acceptable, that you will see widely out in the wild. It is a fantastic language. Now, there's some stuff that it's really not good at. And I have a lot of complaints about the Python language, but these are not complaints that newbies will notice or understand. So I'm not going to go into it. But it is, as a starter language, it's fantastic. I would recommend every day of the week that you learn Python before you learn JavaScript or C# or Java or God help you Golang, or C or C++. Personally, C and C++ are like their own animal, like wildly different application, but definitely look at Python. I would super strongly recommend the book Learn Python the Hard Way. It's good. You can get it on Amazon. It's cheap. I think they have an ebook, but.
Kat, thank you so much. I love all these recommendations. I love your discussion of imposter syndrome, which is something that all of us deal with, and to know that we just get better at recognizing it. I think that's really powerful. And thanks everybody for your questions and for this presentation. Kat, I'm hoping that, thank you so much for giving us your Twitter handle. I'm hoping that we can invite our attendees tonight to reach out to you on LinkedIn or on other sources and just stay in touch with you. And anybody else have other questions before we head off for the night? Perfect. Thank you so much. Don't forget, next week, we're going to be talking about building our resumes. And for a lot of us who've taken a break or pivoting industries, then resume building gets a little trickier. So we're going to work on that next week. But other than that, have a fantastic week. Kat, again, thank you so much. It was fantastic meeting you.
You're welcome. You too. Have a good night.